Hello and welcome back to another little video. So the last video kind of finished off with an interesting problem. The gist was that if we had this string here, it doesn't actually have to be this string, it just has to be a certain character length. So this was 55 characters long, and so I tried a few different things. So in here we have example.c, and perhaps if I yoink up, yeah, and again, and yoink that up, and we can yoink that there, and maybe just get that, and this, I think, maybe to be like that. So what was kind of interesting was if we had, well, in fact, let's kind of, because I've got a thing going on, I kind of want to check out test and get, yeah, maybe I can just do it on here, because this is before I fixed it. So here we can still have that because that's kind of just in our stash, and I think the strlen had to change to size of, and size of kind of works, but we need to do this instead, which will make a static array, and see, we'll just do what it's told. Theoretically I should do size of test divided by size of 0 character, but I know these are characters, so the size of is 1, and this is just for testing. So if we did say this, we get a SHA-1 sum, and it starts with 3dB. Whatevs. If we do a GCC, we get a different number for that SHA-1 sum. So what I want to kind of see is if we do it without the E on the end, and maybe if we go down to here and find the grape and subtract off the E. If we now run this, this is not doing, we need size of -1, and if we have the E on, because it adds a null byte at the end, and I don't want to use that. So if I did that, that is with the E, and it should be 3dB, but I now want to try it without the E. So if we just yoink that E off, and if we now run this, we get the same number as the built-in SHA-1 sum, which we're assuming is correct, because it's been running for yonks, I guess. So I guess this is kind of interesting, and my first thought was that it was to do with padding, because that's just kind of how things go. Because what happens is we pad block at the end, and then we process any remaining block. And so in this pad block, we do a bunch of things, and it's kind of weird. And I've got this RFC here, and I think apologies, it's in the, well, I could open it in this, so this is 1951 and 3174, so 3, so I want this, and then 3174, and now be gone. Now it's in slightly darker mode. So in this, it has a section about padding, and it's kind of a bit wordy and whatnot. But the gist is that you add a 1 bit and then a bunch of zeros and then 8 bytes of kind of specifying the length of it, so 64-bit length. And it's kind of weird that it talks in terms of bits, because your input stream, we are not doing it in terms of bits at this stage. It seems like we just do it in terms of bytes. But I guess we could get to a stage where we do it in terms of bits. So what I had, and this seemingly worked for a bunch of different cases, but I didn't test the edge cases. So 0x80 will basically set the very top bit, and all the rest is 0. And this check here was basically saying, is there room for the 8 bytes of length or not? And so if there is not, it goes in and it clears out the rest of this block, processes it, sets IDX to 0, and then here it should go up to 8 bytes before and clear it, and then here it sets all the length, and then outside of this, after it pads it, it processes the block again. The problem is this text, if we have a little look-see, so without the E, it's 54. With the E, it's 55. And we're kind of looking at this block size, which is 64. And if we look at 64 minus 55, we get 9. Now, interesting to note, because this would suggest that there is space for the 8 bytes plus the 80, but it is going into this kind of loop. And the reason why is because of that equals sign there. It's literally it. So if we I don't know, check out main, and if we look at that file now, it's kind of magically gone. And now if we run this thing, we get C3, and if we try it with the SHA-1 sum, that one, we get 3 dB, which is hey, no, this is not right. Is it reset it? We have not got the E on the end. So now we get 3 dB, which that was the test case that was failing in Codecrafters, and that was in the the Git course. So I've fixed this, and there is now a version 2.0 which fixes this issue, and we can even see what it was, and it was literally bumping the version and removing that, and the last one was just me bumping the version, so nothing to be afraid of. So that kind of means that this Codecrafters Git is maybe working a bit better. There was another dependency, reverse dependency I had of that SHA-1 library, which I've now updated. It was in the BitTorrent project, so that potentially could have run into the same issue where it was doing not like a multiple of 55, but a message size that when it's kind of like a circular addition. So if it would end a block on the 55th byte on the last block, it would kind of trigger this for any for any message size really, and it's kind of like you'll have the length and you hash it, not hash it, mod it by 64, and if this is equal to 55, then it would trigger. That's kind of what I'm thinking. But anyway, enough of SHA stuff, because I thought I had finished with it. It seemed like a very simple spec, and I mean, even if we look at it, source, SHA-1, if we look at it, it's like less than 200 lines of code. So I thought I just done and dusted it, but padding, turns out, probably shows the need for more test case, I guess. I've just got one test case in, and I guess I'm testing by doing. But I guess this means I'm going to say that I can now read tree objects, because in in here we can ls tree. We can do some stuff, and it will kind of complain about that. But we also have to give it a tree. So if we do something like that, we'll be able to ls that tree and kind of see what happens. We haven't actually done the right tree, which could be potentially useful, but I have a feeling that's what we're doing now. So right tree. So what does this do? Current state of the staging area, and so we don't have any notion of staging area and working area at the moment, and I guess they're saying that is the assumption that they are making, that we don't really have a staging area. I wonder how Git kind of implements that staging type thing, because you can kind of have some interesting cases. So I don't know, like if we can rm zlib.c, we don't actually need it, but that means that now we've got some stuff that is begone. Now we should have like an untracked file. If we did that to there and get that, then we so now we have a new file, and we can potentially get is this that's 2025. All right. What about if we look at Vim source and maybe look at this, and I don't know. Well, we're going to be adding in a new command, so we can kind of start it, I guess. Write tree, write to tree, and so this can be write tree. And so now if we go and look at the status again, so it has like this in the staging area, and this is not. And I wonder if I want to kind of demonstrate another kind of thing where, right, so we've got right tree. We haven't really implemented it, but if we get this and maybe go here and do we have unimplemented? Yeah, so we can do something like that. And so we could do get add minus p, and we could add that one, but not that one. And now we have like a staging area where source main is being edited twice. Well, it's edited in the staging area, which is to be committed, and we also have it edited just in the working directory. So I kind of wonder how it kind of tracks that. So we can kind of have a look at what Git directory has. I kind of want to like, can I like tree exclude? We can't do. Can we in this tree thing? I didn't know that this did this. We can minus I guess. That's what I'm guessing. So if we minus I dot objects, and we can still look and get. It still gave me all the objects. Right, so what I kind of want is to see what things kind of exist. So it's got this index that could be kind of interesting, and like I just don't care about objects. Is it because it doesn't actually have that? Yeah, cool. Right, so here we can kind of see various states of things. So maybe I will have a look and kind of see what things have, because I am actually interested in how it knows that source main has been, some stuff has been committed and some stuff hasn't. And I think my above and beyond for this challenge will be having that staging area, if it's kind of easy enough to get out of here. So what are things say? We have like a commit message. I feel like this file shouldn't actually be here, but it isn't giving me errors. Because I finished doing a rebase. So we have like config that's not very interesting. All it does is that description. We don't really need that. Head I've already kind of talked about, and that's just refs heads master. So index might be something useful. Index is a certain file. It is a Git index. What does Git index do? So man Git index, add contents to the index, remove from the index. Right, update index and read tree are the low level ones. See, it's probably done this. I don't know. Merge index, multi-pack index, read tree, update. Oh, I did know that. No, that's just right. So it reckoned I should look at like update index, get update index, man get update index. That is the one I want to know. So this does not seem like what I kind of want. So get read tree. reads tree information into the thing. Reads the tree information. Give my thing. Get checkout index. A checkout index. Da, da. No, I'm not too sure. I wonder if the old docs kind of kind of talk about it. Staging. So that's if we doing something. Yeah, it's kind of. I wonder how the. It is reasonably large. Oh, I like it. It looks. So that has a few things going on, but it's really only it really hasn't changed too much, but this has it kind of looks like the entire tree, like it's got all the file names and whatnot, but somehow that must say what it is. Yeah, maybe I'll do a little thing. So in old DuckDuckGo, there is a thing somewhere. You can duck.ai. They've moved it. Right. So what do we want to do? We could try different things, but what I kind of want to do is how can I read the .get/index file? Is there local command that will pass their docs for how to use it? Do something like that. See if AI can help us, because AI is taking over the world. Yeah, but I kind of want to know how to like pass. Yeah, so golly, there just isn't a. Well, I mean, we don't know if that is the case, but right. Do I have a checkout of yes, I do. We is a big one. Right. So what do I want to see in this? So in documentation, it reckons it has stuff here, and maybe I can do a grep for index in there. It has a few different things. Well, I guess I can do maybe a nicer one of index, but keep it See, it is just in 1,000 places. Um, um, maybe I want to take. See, it doesn't even have a cache.c buddy. It's got a cache tree.c, which maybe is actually what I want. It's a tab language. Right, so this is like. I wonder if I ever have. Alright, so this does have some stuff that isn't really what I care about. I care about if like .get came before that. Unchecked cache is stored in the that's if we keep that in the cache. Cool, talks about an index. I mean, what does that say? Get ls files. Does that, and stage does that. Which I guess that has just something in there. So if we what were we like editing and whatnot? Well, we can even see get status. So source main has two things. So if we search for main and come over here, grab that and get cat file minus p that thing, it should be that. And if we do a diff of that with what it actually looks like, we should just get the output of not that one, we should just get the input of that source main. So that's if we want to do that, I don't know. I kind of, it's weird how that it is. That's just an outline that can go away. Yeah, it's kind of odd that it kind of alright, did that take me to there and exit? Sorted list of path names, each with permissions in the SHA-1. It kind of seems like the like it's just giving me a tree, and I wonder if that is the case. So if we get this, and what does it have? It starts with DIRC, and then like a bunch of bytes. And let's have maybe have a look right, so we don't have anything there. If we like echo A, so A and get add A, we should have something in our index, right? And get ls files. So we should be kind of looking for something akin to this. The file name is kind of just nestled in there, but it's got like a lot of extra bytes that you kind of need to worry about, like what do the 2 and the 1 start. They could be following. So in ASCII we actually have start of heading, start of text, end of transmission. So these like 1 to 4 could be kind of used as that, and I do see that there are some 3s and 4s and 3s and 4s, and the 2 and the 1. So this 2 was what, start of text, and the 1 was start of heading. So start of text is there, start of heading is there, and then this G must mean something. I don't know. Well, I guess this might be our bytes that we kind of want to look at. So we should get a... Oh, I'm going about this like quite a weird way. We should have a text in there somewhere. But not like hex, like actual bytes. So we want the actual bytes 7, 8, which means that surely that would mean that it would kind of fall in here. So yeah, maybe this 7, 8, yeah, 7, 8, 9, 8. Cool. That is our little hash, and it ends. Let's do that. 7, 8. So goes from here to the 8, 5. So that is 1 hash. So what happens before that? We have like a 2, which could mean that it's a hash. I don't know. This stuff up here, I don't know. Because like we've already got the hash of what is. What else can we get from so it reckoned cache tree was like maybe read cache. Yeah, read cache is maybe something I want to look at. I do also want to do a maybe do something like that. I want to check that like copying, yeah, copying. What have we done? We're under the GPL, so I probably shouldn't look too hard into it, because I'm releasing under what we do, MIT. So the problem with MIT is it's a bit more allowing than GPL. GPL, your everything that derives from it has to be GPL as well. So I think I want to just avoid kind of looking at that. It's a shame. I might have to kind of reverse engineer kind of what happens. Like I wonder if we look at the current index, we should have that. And if I like echo B to A, and so the index should have changed in some way. But potentially, if we did the alias, we should get a different hash, and it should be in the similar location. I just want to check a thing. Yeah, I was thinking that. Just, ugh. Yeah, thinking about my keyboard, my poor keyboard. It's got like some stuff on it, and I've tried isopropyl, and it's just not budging, at all. Cool. So this is a Git book. I kind of want to like. Is there anything explicitly on the index? No, that just didn't really. Can get it in a few languages. So in this, staging, interactive staging, and yeah, I don't know. This is interesting. So I can search for this index, and we're just looking at. That was actually what I want. Get index format. EZ. How does this not get like kind of shown? Right. So I guess from that we can work out what the index has in it, and we can potentially. This has like a lot of stuff that I thought it probably doesn't need. Right, so all binary numbers, network byte order. Can we maybe make that so it doesn't scroll? Cool, SHA-1. Right, so we could have repos that are there. We are version 2. I guess that means that we have the DIRC, excellent. We version number 1, 2, 3, 4. We have just 2, so that was just 2, and this is the version here. Perfect. Then here is the number of entries. So we have 1 entry. This is looking kind of cool because we have thing. So if we kind of add a B to the mix, and if we have a look at this, we should get 2 there instead of 1. So it was 1, now it's 2. Easy. Yeah, I'm wondering if I should do this kind of. Like you kind of want to read the current index, and like, does the index? So in my temp thing, like if I just rm get index, and then go get status, it thinks things don't exist, and so if we add a, that will just instantly create the index. Interesting. So I wonder if at some point we need to create this index. Anyhow, what happens next? Number of sorted entries come, and we have, right, so we need the index entry now. Fuck. Also, that's right. index entries, ascending order of the name field. So yeah, we could write this. We can like search things. We can sort things. Surely, if there is a directory, so if we enter C to C, C/C, and if we add that, surely, and if we XD this, we should have two entries, and the first one, so it does do C/C. I suppose because this isn't describing a tree thing. Right. Git has like heaps of stuff that I like just don't really look into really. Right, we just have like some mode. Right, so we should have. Cool. What if we do a stat of A and maybe stat? Wow. I kind of want to get. So what I'm seeing here is these 4 bytes, the number of seconds since I touched it, and it kind of makes sense because that used to be a square bracket, then it went up to a thing. So this is again the C time, and so I think I can kind of get this from stat if we do minus C format. Right, so what format do we want? We want, what was it, C time? C time, is C time the, last time our file's metadata changed? I think that's this, right? And so maybe if I do something like that, minus C percent Z of A, but I want percent Z. And was that the change time? I mean, it's the same as the modified time, so it's kind of hard to know. But yeah, so that will be that number, golly. And then we kind of need to like printf that, printf this as a hex, and we can just give it that same thing. So this should get a thing. If we get the XXD again, so we have a 6, 7, A1, 7C, 3, 4, and that is these 4 fields there. Perfect. So the nanosecond one, like, I would imagine that like you can kind of just fill it in with nothing. Though I guess Git uses this information to like recreate the files. But yeah, m time, so another kind of 4, then another 4. So now we're at all the zeros. I kind of want to, I did a thing there. I want to kind of come up and say we are at this point here. Right, so this is the device, and so we can perhaps see that. So stat cd temp, so stat a had a device 252, so this, we were one of the zeros. This one here probably. So if we get the man stat and device number in decimal or hex, so we can get %D or %HD. So yeah, minus C percent capital D, so that should get FC01, and that is what we are seeing now. Perfect, perfect, perfect. And the I know is just some more stuff in the thing, so we should have another kind of 32 bits, so 1, 2, 3, 4 bytes, and then we get our mode. Now our mode is actually of note because we use that to kind of print and put in our tree, because when we do like the ls tree, we have a mode. This is the mode of all the files in the tree is not what was that loading? Ding ding, time is up. That's right. Yeah. Easy, easy, easy. Right, so what do we have here? Our mode, we're kind of looking at this 814, and so this stat has mode, I guess. So I guess we want like %A, or maybe just that %F. Percent F of that, that's not what we want. %A was a thing, but so this is in octal, so maybe we want this to be like that. I don't know. Can we just not have it in percent lowercase f was what I want. So this was 81B4. This isn't what we're seeing for A. It's like one off though, and kind of that place there. So I kind of want to from maybe the like I don't know. I kind of need this to be printf, and this can be like it's already in hex, which is the problem. I forgot what I want to do. I kind of want to convert this into octal, but like from hex, which yeah, kind of requires doing something. I don't know. Maybe I just want to see that this has A1B4 and was so that one also has the same thing. It's interesting that this doesn't kind of pick up our thing, and this should have like another file down here. So this is also 81A4. Interesting why it is that. Right, so anyway, after these we have 16-bit unused, so that's just these 2 bytes, easy. And then we have a object type value, so this is just a 4-bit one. Alright, so this is just looking at and like all the things binary numbers in network byte order. So this kind of means that our 4-bit number at the moment we kind of have none of the above. Because it's a 4-bit, it kind of means it's got to be one of these digits. I guess if we started from that end, that kind of makes sense. It is 8, and then, but then this E doesn't really make sense because that is what do I want? So like if I look at binary of E, it is a bunch of ones. And yeah, the 3 is, so like 0, 3 has a bunch of zeros and then these 2 ones right at the bottom. Or it's 2 ones, then a bunch of zeros, and like none of these kind of make sense. I don't know. I think I perhaps need to maybe go down a different track. So I guess getting back to the original thing is we had a write tree command, and that's kind of what we're wanting to do, and we're perhaps just going to assume that everything is in the staging area, just to avoid kind of yeah, there's a few things that might need doing in this, because there might be stuff in get ignore, which we aren't really kind of tracking. I don't know. I think I'll come back to the index tracking because it does seem kind of cool, and it seems possible. So I guess here we need write tree. So we have unimplemented, and so if we did write tree, theoretically we could change this to be our thing, and I guess we would yeah, we don't need the 582. Oh, it's giving me the usage error because the write tree has returned nothing. So if we did something like ABC, then it would probably complain about a different thing. ABC is not a valid hash. Easy. So what do I want to do with right tree? We need to do this like iterate over everything, and we need to like write each of these objects. Create a blob object and do that, and like we will. That's not what I wanted. That's what I did, but it's not what I wanted. Right, so we get trees and stuff, and we do this. So I wonder actually. We've got a few things in there. So I wonder if we do get in it again, does that mean no? So maybe if I just get rid of that, and so if we look at objects, we don't have anything, and if we get add a, we can do a, and if we do that's added an object for us, which I guess that thing was in the index, the 6.1 index. I've like lost what. So if we did this, we should have a 6178 somewhere. 6178, yeah. So that's our little hash, and we got all the file information beforehand. So I guess that kind of means that you need to create the fix me in the future. This will pass dot get slash index, and we had some docs for that. Not that doc, not that doc. This doc here. And do I have that local actually? Get format index. And get format index, and that should kind of show me what I need to do. Right, so now we need to go through and I think I want a fix me handle dot get ignore, because surely that should be a thing. But for now, we need to iterate a directory. So how do we go about iterating a directory? So I guess we kind of need to like there'll be like man open at so this has some things. There'll be like a thing that you do to kind of read a file. Man, LSat, it's the read directory, because we haven't actually done this. We've progressed through, and I've forgotten off the top of my head. Yeah, it's like this dir int thing. Ugh, I recall this. Right, so we'll have this. Right, so we'll kind of start from here, and we need to get our So I guess we need to somehow recurse. So this will be recursing into like right tree object, I guess. We have the ability to like hash an object. So hash object is actually doing the right when we do this. And so that does that. And we only really do it if we do that. And we're just creating the object. We're not really doing the dir and stuff. But we do a bit of stuff. So what are we doing? We're doing right tree. So I guess I kind of want this to be maybe right tree, and this is going to take constr path, I guess, and what it's going to return is probably a hash. Yeah, so maybe this is actually going to be UNHT pointed to hash of SHA-1 byte length. For a bool. And then here we can probably just and then this will probably also be necessary here. So here we kind of want to do like kind of just write tree of dot. This is opened. Potentially, I might do AT, that sort of thing. And that way we can kind of do an open at and kind of do things like that. Right, so if this thing didn't succeed, we probably want to return 1, and this is interesting. What do we want for right tree? It's kind of got two things. I think at this stage, I would do if argc is greater than 0, unimplemented items for right tree. That is what that handles. Otherwise, we do this. So the right tree takes in a dir fd, and so I guess here we would guess we need to include this stuff. So include, it's just dir int. So it's not very platform independent, I guess, at this stage, because I'm using a lot of Linux stuff, but it is what it is. Right, this is all good. That's that. Oh, that's where that came from. Sorry, I just keep on having a look aside. Right, so here we will get a dir p. And the EP is like, yeah. Right, so here we can have like dp equals open dir at. I'm assuming there is an open dir at? Is there an open dir at fd open dir? Is that what I want? Fd open dir. Yes, this is kind of what I want. So fd open dir, and we want the dir fd. And will that do the right thing in the case that this doesn't talk about yeah, I wonder if this kind of fails. So if dp equal null, perhaps this can be assert dp not equal to null, and I wonder whether this will complain straight away. So if we go to here and right tree, we need to do a return. We'll do a return false for now, and here we can do a return 0 for now. That's all right. Right tree wants more things, does it? So this will take in a hash, and so this can be uint8 d hash, and it was 1 byte length, and we'll pass in the thing. And I guess that's if not, otherwise we unimplemented right the tree. So do I need to do anything with this one, or do I just print it out? I think it might just be print it out. Oh, it's kind of interesting. How do we go about in source 1 passing in that hash? So we just we know it's that length. That's all right. So we don't need to do the memory, and we don't need to do the memory because we just get a thing. Right. So EP isn't used. That's all right. We haven't actually done anything with EP yet, but we can just kind of comment it out. Just so it does that. Right, so yeah, this assertion kind of failed. So I wonder what I need to do to kind of I need to kind of open the directory first. So man open at so I guess int root fd, and this can equal to that, and I guess I want to do open at root fd, and just dot, I guess, and the flags, I forget what they are, just like read only should be fine. Right, so now this kind of is going to return a thing, and if root fd not actually no, this fd is legitimate to do that, and I think because this needs to get closed, and so like maybe this gets asserted that root fd is not equal to -1, greater than 0, because the bugs return value has to be non-negative. Right, so we should get that, and then after the case we should get that. And so now I kind of want to do defer there, and maybe an undef return defer, and we can just return ret, and up here we can have int ret equal 0, and define, so I kind of want to define return that one, and yoink that there. And here we can put in some things. Fix me work inside folders. I don't know how that's going to happen just yet. Right, so here we should have a point where if root fd not equal to at that thing, then we want to close it because we have opened it. And so this can get there, and here we can return defer 1. That seems all right, and maybe we can have the same thing just up here. We don't support anything. Cool, so now this should hopefully, it gets to a point where we're memory leaking easy. That kind of means that we aren't doing the close, right? Or is it because we do this and now we need to close this? Yeah, so we need to do a close dir on dp. Easy. So this could probably equal to null, and this can equal to null, and we can do a similar thing here, and we can probably do all ret equals false by default, maybe true by default, and here we can just do a ret, and here we can have our defer, and maybe undef the return defer, and in our defer, if dp is set, then we want to close dir on dp, so we don't do that there, and that is potentially all for now. And so if we do this, not used, it's because we don't actually use this return defer. Oh no, I'll just do that just so it kind of, so this is, we're getting a 1, So it does actually kind of mean that we hitting, in this case, likely. So I guess when we're right treeing, we actually want to return true. Yeah, cool. So now it has done that. So at this point here, we should do some things. Right, so we have opened the directory, and we can do stuff pretty much. While EP, I kind of, I don't know, I kind of want it to not be in a circ because it's kind of hard. But right, I don't know. So this is our file name. So if we do printf file equal that and do something like this, and epd name, is that what we want from me? And so now we don't need to kind of care about that. We still kind of need to care about that. Right, so now it should have a bunch of things. So we want to kind of ignore some things. If str smp of epd name, if this is dot equals 0, we want to continue, just because we do, and maybe if we add another dot and do the same continue, and so we also want to want this to be get. So if it is equal to get, which is one of the things that is there, then we want to continue. And I think this we will kind of jump in there. And I think because of that, I can maybe do something like this. Do something like that, and that was the one that I wanted, and we can just do the continue ones. And so now it should kind of not print out those files. And at this point here, we need to I don't know, do some things. And I guess this is also, we want to handle get ignore, but also handle staging area, i.e. Get index. Won't be today, I've decided, just because sometimes you can't do everything in one day. Right, so if we get to this point here, we have our directory, and so what do we want to do when we get every directory? We kind of want to, if it's a file, we want to do something, and if it's a directory, then we want to kind of recurse into it and then do something different. What is it that we need to do? This thing, we're kind of needing to have like a kind of tree object as we're going, which, yeah. Maybe I will, I have a thing in source zlib, I think, and like this notion of an array, And I think I kind of want it to be in here as well, but maybe we can just call it like almost an array T. UN8 array T, something like that. I don't know, it's very hard coded. But in not in SHA-1, in fact SHA-1 can probably go in case I do a thing. We have a thing, ensure, is this what I want? So we have this thing, which we can chuck like here, and so maybe this can be just array ensure this, and so that would be array and array and array and array, and we can take away these things. So what do we need instead? This context can just get set to that, so maybe in here I actually do replace of a context out with array, and do it a few times actually. Right, so that will do that. So this is just taking an array, and we can just take an array. We don't need that. We can do that thing again and make sure that does that. Here we pass an array, and we source name easy, and we can do the same thing there. Cool, now we have like an array. It's bizarre that C has never, didn't have one. Well, I guess you don't need it. Sorry about jumping all over the place, but it's just the mode I'm in at the moment, I guess. So now we can have a uint array T type, and this is going to be our tree data, and we can set it to be null initially. And in here, if we have tree data dot data, if something has been set, then we should probably free that data, something like that. Cool. So that means that for every entry, we can kind of start building up a tree. So this kind of gave me a thing. So what is it that we need to do? We need to get the tree, the mode, for each entry. So this is like each entry at the moment. We're going to get the mode, the name, and a hash of the thing. And the hash is the hash of the blob, I guess. Blob or the tree, depending on what it is. We only kind of support those two types of things. Right, so do we actually do a stat anywhere? We include stat, but we only use it for the format thing, I think. But what I want to do is actually get stat, and from there we can get the information that we need to build up this thing. Cool. So, I guess we'll want to have this kind of somewhere. Maybe in a right tree. Yeah, that can be a thing. So this is going to be case somewhere, but we probably want to do stat. And how do we do stat? It needs like a separate thing, and we can do f stat at as well, which is potentially what I want. F stat at, so we give it the dir fd and the path name, which we have the path name and the dir fp is the dir fd, but this fd open dir, this said before, fd open dir returns a directory stream for the thing by the open file descriptor fd. After a successful call, fd is used internally by the implementation and should not otherwise be used by the application. So I think I need to do almost a dupe on this file dir. Because I still want to be able to use it. Well, I guess what does read dir kind of give me back? It gives an inode. It doesn't give any. Well, no. What does the open dir? So this gives me a thing. It gives me one of those like kind of private thing, but can we get the useful file descriptor back from dir? Underlying file descriptor can be obtained by this. I think that is what I want. So man dir fd, is that what I want? Is that what I want? That's all good, all good. Right, so in this we get the dir fd, returns a file descriptor, is the one used internally by the directory stream. It is useful only for functions which do not depend on or alter the file position, such as fstat or fchdir. So this is actually maybe I'm just like kind of nervous because I also need to recurse into this at some point, and to do that I would need to do open at on the file descriptor. So I guess does the man open at does this kind of all right. Like I feel like it might be allowed. I don't know. It's kind of weird. So in this thing is where I kind of want to look at things. So in this thing, right. So we read a dir and do that. So if we do, well, so I'm wanting to do a stat, and it did mention something specifically about if stat at if stat and I would imagine if I can use it for fstat, then I can probably use it for fstat at. think this is potentially what I want. Cool. So we'd want an fstat at, and what does this give us? So we need a dir fd of dp. I don't know, like, I just want to know whether I should dupe it or not, and like, it's kind of annoying that it isn't clear, I guess. EP the name, so if we open up that thing inside of it, we can provide us the stat. So this is struct stat. File stat, we can call it file stat maybe, and the flags, I forget, we can just call that with 0 flag. So what will this give us? This will give us a probably some return values. Right, so if this maybe we just want to assert that this equals like we could open it, right, and then here we have like ifnt, this had like a thing, so this was file stat.st mode, so this will help us know what things are, and like what was the maybe also do like well, I'll do that, a printf of mode, maybe in octal, equals, and this has like jo, which I sp dot st mode, and I kind of actually recall seeing J following in right, so that's just because they do a odd cast. We don't need to there, I guess. What does this kind of do now? Right, so we don't have SB, we have file stat, and we don't have that. Right, that looks like it did some things. So what do we have? We get like the mode as it's meant to be kind of written. This is looking good, and when we get a directory that kind of does that, and it didn't really talk about, so this was, yeah, right, directory, but we kind of like drop off the mode of the directory, and yeah, so it does print tree. So what do we need to do? We have a bunch of things that needs doing. I think in this case, we're going to do a thing, and in this case we're also going to do a thing. So if it is a directory, we kind of want to recurse into this. Otherwise, if it's a file, we kind of just want to print out the mode. So we can do this. We can, well, this is going into the array data. So, how do we get to do that? Printing into one thing. I guess we can. We know that we can do SN printf, and we can do like array ensure, and we probably want to pass in the tree data. So tree data, and we want to ensure how many things. We want to print out the mode, which was going to be 6 characters. So we're going to have 6, and we're going to have a space after it, so it's really going to be 7. And well, it's going to be 6 for the mode. 7 plus strlen of epd name, and I think that is what I want there, and then 1 for the thing, the null byte. That's not what I want. That's right. So we ensure the amount of space is there for it, and then our SN printf, we can kind of print to a string, which is kind of what we want. So we print into tree data, tree data dot data. We print to there, and we are saying this is going to be a max of 6, and we're going to print out our octal, our mode in 6, and I think I want to do an assert that this equals 6. If not, there's like some issues. But no, that's only really what I want to do in this case here, where we're going to get the mode, and we're going to print that, and then the space, and then maybe just the thing, and maybe I'll just assert that this is greater than 0, and after the mode we also need to do file, right, no, it's epd name. So we have this 6 is wrong, this should probably be 8 plus strlen epd name, and this is really tree data plus size, because we might have already written some stuff. And right, so that's the thing, then we get that, then we get that, and that can just be the rest of the assert. Right, so that's writing that and the null byte. So I guess this can is that what we want? Yeah, I think doing just that kind of does the trick. Right, and at this point here we want to do a hash object, but the hash object, wow, no. We need to see, well, the mode is taken by the mode, and we've kind of taken off that. Alright, that's fine. I wonder if, so at this point here we want to print the hash. so really it's plus that plus SHA-1 digest byte length. Make sure we have everything available, and here we want to get the hash, and then we want to golly, this is going to return a thing. Written equals that, and this whole thing actually returns it is an int, so maybe I'll do an assert written is greater than 0, and then want to do tree data dot size plus equal to written, and I think I want to just do a cheeky assert that tree data dot size plus 8 plus str len epd name, whether that whole thing is less than or equal to tree data dot capacity. Make sure that we have enough space, we don't go over. Right, so here we can do that, and maybe let's do another cheeky assert, because we are about to write in all of these. For now, we haven't actually got the thing, but what we can do is do array of pin bytes. Is that what we want? But the array of pin bytes will kind of do the array of sure, but that's alright. So we want to give it the array, the source, and the length. So this is going to be tree data, and the source is going to be our hash, and our length is going to be SHA-1 digest thing. And that will just do that. And like this append bytes will actually do the trick for us. Right, so at this point here, we've kind of finished that, and there's no more null byte after that. So what happens if it's a directory? We still are writing the kind of mode in the name, but the mode, I think we just want to do sifdir to say that it's a directory. And here we do that, and here we get the hash, and to get the hash here we actually this is keep on going on the stack. It'll keep going on the stack. Here when we get the hash, we actually want to do write tree, and we want to write tree at the so we want to give a we kind of want to open open at so this open at the flags was like read only, I guess. Don't really care about that, and flags is down here. So what is flag? See below that, and the mode we don't care about. Right, so this is going to return us FD. So here we do like a if not right tree, and we would pass in that FD, and I just want to be able to see what is up the top there. So we FD and then the hash. So if that was not able to be done, we probably want to do a close of FD, and we probably want to check that, maybe do an assert that FD is greater than 0. And so we would return defer false. Otherwise, we can just write the hash as normal. So I guess the hash is just always these two lines. So I wonder if that could kind of get taken out. How do we get the hash in the scheme of this? So we kind of have hash object, hash object, this command here that does kind of do this. Oh, we can read file contents. See, this is I kind of want something like this, read contents at and the FD, and here we can maybe do something like this. And do two different things depending on whether you pass it a file name. So if we pass it a file name, then this kind of just will be alright. So if this is if a file equal null, return false. Otherwise, we will do if we kind of want to do read equals file read contents fp, and we'll give it the file and the data and the size, just like that. And then we'll if close on the file and return ret. So that should do that, and don't need to change anything there. We do want to not close the file there, I think. And if we want to do this open at, it's going to be quite similar to this, except if open at, I mean this one will have it, no it doesn't, how do I want to do that? I kind of want to do, well, maybe I want to do open at, well, it didn't have anything in there. I kind of want to do so we can do an open at. So an open at, we do path name and flags. So here we want to do fd, and we want to give it that sort of thing. And I think now, so this is going to be that, and we probably want to assert fd is greater than 0, and then we can get file name. So there is a way we can take a thing. Well, yeah, fd open. Actually, that's the one we wanted. Fd open. Was that the one we wanted? Yeah, and that just takes the thing. File equals fd open. We'll pass it the fd, and we're wanting to read it in binary mode. And I think that will kind of do that. And fd open, does that mean we like the mode must be one of these, compatible with the file descriptor, file position indicator of the screen is set to that belonging to, and the file descriptor is not duped and will be closed when this is closed. That's cool. We can do that. So I think if we get it, it's like kind of in a weird case, but here we should kind of get that. And what we're trying to do, we can maybe do stuff like this. Right, so here I did not mean to do that. Pointer targets and passing different assignments. That's because we want this to be just right. Embedded 0 in format. How are we not allowed to do that? Maybe I need to do something like we can even do it as a character. Alright, see what happens there. This we can do a char star, and it will probably not like that, but we can do that. Right, so now if we do this, should do some things. Right, so I guess it's not doing anything exciting for me. I want to be able to kind of see what the tree data is. So what if I do hex dump of, and what do we need for hex dump? So hex dump was just the data and the size. So we can do tree data dot data and tree data dot size. And what do things look like? So things do look like we are kind of writing things in. We're writing in the mode, file name, null byte, and then a bunch of things. The hash is not calculated at the moment, because I guess now that I did this, I now want to kind of read the data. So well, like what was it? It was like read file read contents. So file read contents at, that's what we want, and this whole thing takes dir file name and uint data and size. So this is going to be dir fd dr, is it dr? The doctor is in. Dir fd dp dp and the file name was ep d name, and what were some more things I need to do? Data and size. So I guess I want to give it my data and my size. And so here I will have uint t data equal null and long size. Well, did it give me a long? Yeah, it gave me a long equal 0. And so this whole thing, not that either. Not that either. That one. That'll do. This returns a bool. So if this could not happen, we should probably do a thing. Now, if it fails, does it clear any data that we kind of write? I wonder if that is the case. Yeah, so if not read, it will free the data. No point having invalid data. So, if this is the case, we were unable to read a file. I think I want to just do assert this file can be read, but like potentially it can't, but we'll just assume it does. Alright, so at this point here we now have a data and a size. So what we need to do is almost create another another like blob data. So this is really in aims of getting the hash. So I guess I wonder if I want this to like kind of, well, so the actual blob data, I guess we can kind of create it. We're going to have 8t and blob. It's going to equal a bunch of things. We need to get like the length. This is like kind of turning into a thing. We need to turn the size into a length, and I think I did even have stuff like this. Yeah, so we can get bloblen like this. I mean, this, it's just the same. I don't know, it kind of shows that this is creating the blob. So I guess this is all creating a blob. I mean, it's a bit of copy pasting, but this whole thing is kind of what the thing is. Then it's we do that. Which, yeah, I don't know. I think I'll just do it again. And like, do we need to write the blob out? Like if we're writing the tree, surely we would have to write each of the blobs out. So maybe I want this to, we can have a thing, and maybe it can just take in hash blob, maybe blob, and whether we're going to save it. So we're going to have some data, and we'll probably have the size, and here we should probably have a right flag. So here we can do this. So after we do this, we can probably just do what was it, hash blob for file data size, and right blob, and that should probably just do all of this good stuff. Otherwise it will just print out the hash. So do we put the hash in there? No, we do not. So I guess this should probably take in the hash, and don't go there, go like up here maybe. Right, so in here we have this, and so I guess this is even a t hash, and it's SHA-1 byte length, easy. Right, so here we do things, we create blob, so return defer doesn't really exist here, but that's perhaps a thing that we need to do. So we would have something like this at the end, and this we kind of want to uint blob equal null, and here we would define return defer, and like maybe if we search for that, probably down would have been better. I don't know, like just give me. Alright, so here we want to do that. Right, so here we can kind of start saying return defers and stuff. And maybe this was just right. Easy. So the context, I think we need to kind of move into here. So there was a zlib context. We will have it in here. This should probably say something like, well, so we have that, and blob, we want to free blob, and if context.deflates.out.data, we probably want to free that context.deflates.out.data. Is that what we should be doing? Yeah, so that one there. Right, so the hash objects command, we should just get that, and then we just do a hash blob, and if this didn't succeed, we should do a return defer of 1 and do that, and maybe error hashing blob. It kind of for that. It kind of does like 2 steps because we like create a blob and then do some other things. So does this compile? Ret is undeclared. So we can probably declare it. File data is undeclared. Right, so this is where we have passed in data and size. So this is data. dirfd is undeclared, so this came from inside of here. So it started off there, dirfd. So I think we can safely kind of just use it up here. Right, so call to write is not a function. Called object write, have we, we've done that, right, blob, we want, yeah, this thing here, and blob, right, hash is undeclared, is that correct? I thought hash is declared. So where are we here? We're in this hash object command. So hash isn't actually declared. Alright. Does that mean I just need to do a uint8 t hash, and it's the SHA-1 and that is what it is. So does that mean this is maybe doing something like that? Yeah, that's what we want. But result is undeclined. Right, alright, this needs to be hash, and this also needs to be hash, and we just need to define uint hash is going to be SHA-1 of that thing, and we can bump that out. Right, so what is happening here? We're expecting that. That's because we don't really get anything out of here. So I think here I actually kind of want to do hash blob, and what was hash blob taking? Data size hash and then write. So data size hash and write. So we want write to be true. The data and the size is all good, and hash we getting. Right, so here I think if not this, well, like perhaps we just want to do an assert this whole thing succeeds. And if it doesn't, then that's a different problem. That compiled. Right, so now if we did this, it will hopefully have some different things. It doesn't look like it does. So we, and it makes me wonder whether hash object is working currently. We can look at another file. A exists. Yeah, so we're just getting zeros for everything. So in the hash blob, I wonder if hash is kind of like carried in. Right, so in this thing, we should have hash, which is just passed in there. So here, where do we kind of set hash? And we kind of get it. I don't know why this has failed. What we can do is not that one. Golly. Maybe we'll do a hex dump on that just to see what we're. So that doesn't look right. So this should. It's kind of like offset by 2. So at this point here, what do they have? The header size maybe is. This is bizarre. Printf blob size equals that blob size, and maybe do header size, and this can be that. Sure. Sure. And it was also for that. Golly. Right, so blob size and header size. So header size should be like blob space whatever. Should be whatever it has printed, and it's kind of not. Yeah. Should have just 2 because like this A file just has an A in it, which looks like 2 bytes. BLOB space. I feel like my hex dump is actually the one that's failing me here. I thought I. Alright, source load, is that where it is? Hex dump. So in this. We're kind of in this case. What does that do? That's what we want. And I wonder if that is what we want there. Like maybe if I do something a little bit bigger, like licenses, has some things. This looks like it is kind of not doing the right thing. It pushes out too far over there. So I think this one I weirdly want to be like that. I don't like it being different though. this is like a +1, so what if I did something like that? That does way too much. What about a -1? I don't know, I think I'm just going to keep with that and do with that. But anyway, what does this B do? So I'm just wondering why hash never kind of gets through to where I want it to be. Because at this point here, we have result. It's because we don't want a result. Right, so go away results, and this should probably do the right thing. So instead of result, I want it to be hash. And same thing there, and same thing there. Cool, so now this should give us valid hashes again. So if we do a cat file of, I don't know, like this whole thing here, we should just get the license out. Perfect. So what if we go back to the save tree, the right tree, right tree. It's printing out a bunch of stuff. It's kind of interesting. It printed out more than I would have expected. That's actually, yeah, this has like file equals percent. Don't really need to do that because we are already kind of doing it. So I kind of want to do something like this just to see what data is going out there. So this whole thing is a blob. Is that right? No, I kind of want to hex dump. We do a hex dump. That is hex dump of that I don't want, but this one can go away. And so if we do the right file, we just get a hash, and it looks like a reasonable one. Otherwise, we get this, which this is looking more like what the kind of get tree should look like. So we get do we have a CMake? So this is like inside of a thing. This is not right because this is not in this directory. Is that correct? Yeah, find mouse name cmake dot check cache. Yeah, so that's like all the way in dot build. I see. It's what do we have in this? Oh, this has like a million things in here. Is there a way to like test whether glob matches? So glob is a thing. Find path names matching a thing. kind of want to just see whether something matches. If in match, is that what I want? If in match. Man, if in match. Match file name or path. So this is a pattern and a string. So this is the same as glob. Perfect. This is kind of what I want for like handling git ignore type stuff. But I think yeah, I kind of want this to not be running inside of a thing. Yeah, I kind of need it to find the root directory. And this hasn't run that yet. This is like kind of half and half, like inside my thing, but also kind of not. Like it has some things that I would have thought wouldn't have done it. I think I know what is happening. I think I know. This is happening after every output. So what we kind of want to do is do like maybe a cheeky fprintf to std error and tree done, something like that, just to show us the difference. And what I think is this will have multiple trees. Well, that was my hope. It hasn't got a single one. We write the tree. So that is done inside of there, and that is after we do write tree, we should have gotten to the end. Tree start, I don't know, because I'm also not recompiling. Stop doing that at one point. Right, so now this is kind of doing tree done, tree start. Perfect. So interesting that we've got a tree with nothing in it. So yeah, I wonder why there's a tree with nothing in it. Create blob for this. Create tree blob for this. It's not really a blob, but we need to get hash. So it's kind of like writing an object, but it's also not. And I wonder if the hash blob. So this is a thing that I reckon we could get away with not saying it is a blob or not, and we could just hash objects, I guess. Yeah, I think that's kind of what I'm thinking. Because the only place it says that is, yeah. I don't know. I just need to write the blobs now, I guess. But yeah, coming at it. I think I'll leave it here. I've made some progress and I've talked about some stuff, but I'll leave it here, and until next time, I'll see you.